All right. Well, good morning and happy Wednesday, and thank you guys for waking up and logging in and showing up to class. And so we will take a look at our next lecture, which covers functions in Python. And so a lot of the material. So there we do have a textbook for the class, and perhaps I should have emphasized this a little earlier, but under the modules in Canvas, you have links to books, and this one is a lot of the material comes from Think Python, and so you will click the link and you can just download the book as a PDF. Of course, if you want to actually purchase the book, you can. I think there's links to it on Amazon or something, and you can purchase the physical textbook as well. But the digital one is perfectly good, and we've assigned homework problems from it, and a lot of the material that I cover comes from those textbooks. So take a look at those. Okay, they are a good supplement. All right, let's take a look. So when you think about just programming in general, just kind of this big picture idea of programming, all programs can be reduced to just input, output math, conditional execution, and repetition. And this includes even games. Like if you're thinking about like a video game, you've got input from maybe some game controller. The output is what is being displayed to the screen, and there's math happening, right? Like when you if you're going to play like some platformer like Super Mario Brothers or something, and you push the jump button, okay, there's math being performed which says, we're going to change the X and Y position, going up and down, according to some formula. And then there's conditional execution. Do this if the hitbox for this character, overlaps with another hitbox, then that means, this action will happen, otherwise not, things like that. And then it just kind of repeats, usually with some kind of variation or something. And the way we execute these different bits of code is through function calls. A function consists of, when we call a function, what we need is the name of the function, and we indicate that the function is being executed in Python, usually with parentheses, and inside those parentheses, we put any kind of arguments, the settings of different values or variables that will get run. Okay. And then the function will produce some kind of return value. So here is an example. We're going to ask, what is the type? This is a function call. We are executing the function because there's parentheses. We're going to put in the value 42. And Python says, okay, this function needs to figure out what type of value this is. And it says it's an integer. And so it returns to the screen the value int to indicate to us that the return that the value is int. All right, so if you just write the name of the function with no parentheses, it doesn't call the function. This returns the object itself. It says, if you just write print without parentheses, it says, oh, you are talking about the function print. You're talking about this particular function. Whereas when you call print with parentheses and you put an argument in it, this calls the function. And so now it outputs the word hello to the screen. You can say print the integers 1, 2, 3, and it prints out the integers 1, 2, 3 to the screen. You can give it additional arguments, such as I want the separator between these things, right? The default separator is a space, but we can say I want the separator to be a dash, and it outputs that to the screen. This is just very basic stuff. Anytime you want a little bit more detail you can always look up the documentation by calling help function name. If you're in Jupyter Lab, you can hit Control or Command I, or maybe it's just Control I, and that will show contextual help, and that will kind of bring up another tab that displays the help, and you can kind of move these around if necessary. So if you ask for help on print, it will tell you, okay, print out the value. There's additional arguments. You can change the separator where the default is a space. The default at the end of the print, it moves on to the next line automatically, but you can change that so it doesn't go to a new line, or it does something different, maybe 2 new line characters. The general usual output is system standard out, which just means putting it out onto the screen. But if you want to store it to a file, you can do that as well. So anyway, you can always look up more information about help, and you can always go on the internet and search for the Python documentation as well. Okay, just a side note about single and double quotes. Both single and double quotes can be used to denote a string. Use double quotes if there's going to be an apostrophe in there, or if you want to use single quotes or with an apostrophe or something, you have to escape it with a backslash. So here you can write I can't apostrophe here, or a single quote inside the double quotes, and it has no issue. Okay, but if you do something like I can't believe it, and you start off with single quotes, this apostrophe here will look like it closes off this thing. This part is going to be recognized as the string, and then Python gets confused by this. Okay, it says you can't do stuff like this. All right, so one way you can deal with that is you can escape a symbol using a backspace. Okay, and this will take on a special meaning, and then it will recognize that this is just the literal character and it's not being used to close off the quote. Okay. And then you can kind of reverse it and put a double quote mark inside the thing, and it doesn't cause problems, but this just looks funny. It's not funny. All right, you'll have to define your own functions. Okay, and so here, to define a function is you use the keyword define, def, okay? And then you put in the name of the function, and then you put in any arguments in there, okay? So here we're going to create a function, and all it's going to do is it's going to take whatever the phrase is, it's going to make it uppercase, add some exclamation points, and now it looks like we are shouting. So whatever it is will look like it's a shout, and it returns it, right? And so if you want the function to return an object, you must use the return statement. This is in contrast to R, where by default, the last expression in a function will get returned automatically. In Python, you must explicitly use the return statement. And when a function runs into that return statement, it views it as its job being complete. So here, I've got, hi, my name is Miles in lowercase here. And after running it through the function shouting, this looks indeed like I'm shouting my name, because it's taken this string, it's made everything uppercase, it's added some exclamation points, and that is what is being returned. Okay, and just like all other kind of Python code blocks, we don't use curly braces. The lines that are indented are associated with the definition statement of the function that we are defining. Okay, now here we run into a problem because I give it the number 5, okay? And it tells me that inside our function definition, okay? Inside the function definition, I'm saying what I want next is I want the phrase made uppercase. And as far as integers go, integers don't have an uppercase version, okay? So Python tells me, you know, there's a problem here, okay? And the error messages in Python are actually quite helpful and handy. It outputs quite a bit of stuff, but when a lot of times these error messages are helpful, it will tell you exactly where things are going wrong. Now, oftentimes the error messages become less helpful when you've loaded a bunch of libraries, because perhaps you've written something that doesn't quite run well in the library, and then, you know, now the code is difficult. But if you've been writing kind of your own functions, or if you've been writing your own code and you're working in base Python, generally the error messages are quite helpful. It says, you know, the error came in this line, shouting 5. And just so you know, what is shouting 5 trying to do? Well, the definition of the shouting is this, and the error message is in this line. This is where we're encountering the problem. And phrase.upper is encountering a thing, and it says an integer object has no attribute upper. Okay, so what can we do to fix this? Well, what we can do is we can take the phrase and convert it to a string. So we're going to do string of the phrase, okay? And now that we've turned the phrase into a string, then we can make it uppercase, and then we can add exclamation points. And so if we do that, we can say shouting 5, and then now it looks like we are indeed shouting the number 5 out, okay? And so you can put 5 in quotes. There's no lowercase or uppercase 5, but it's no longer gonna throw an error. Does this feel okay for everybody? All right, let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter E. E as an elephant. E as an elephant is your first view quiz answer for today. E. Okay, if a function returns a value, the result of the function can then be assigned to some kind of object here, right? So here we've got shouting, and we can say, we can take the result of this function, shouting hi, and assign it to the variable name or object name greeting, okay? And then we can, you know, use that later, and we can say, well, what was stored inside greeting? And it looks like somebody is very eager to say hello to you, okay? If a function does not return an object, then the result of the function will be none, okay? So here, I'm saying quiet, we're gonna take whatever phrase it is, make it lowercase, and I didn't use the word object return. And so if I do this, and I say, make this quiet, okay, it will assign this to, this will take the phrase, make it lowercase, and assign it to the object SHH, but it's not going to be returned because I didn't ask for return. So if I ask, well, what is whisper? Okay, and I ask what is whisper, and nothing actually gets returned, okay? So this is the default of a none being returned is nothing will output when you ask for that. And if you say print out this thing, it says what's in there is a none object, basically nothing, and the kind of a null value, and a none object, right? The type of this is a none type, okay? And that's because I forgot to use the word return here. So the function just is not going to work, okay? In some cases, you want to return multiple values, okay? And you can return multiple values. What you do is you group all of the values together into a tuple, okay? So you can return multiple values, and it will group them together in a tuple. So for example, we can take a number, and we can say the square is going to be number raised to the second power. The cube is going to be the number raised to the third power. And we can return all three values, number, square, cube, just doing return the number, comma, square, comma, cube. And this will group these three different values into what's known as a tuple. And we'll talk about tuples in a future lecture. But basically, if you say, I want the powers of 3, you get back 3, 9, 27. This is what we call a tuple, and these are the 3 values in there. Okay, and one nice feature of Python is called tuple unpacking. So you can take the values in a tuple, and then they can be unpacked into separate elements. So for example, we could say powers of 3 and unpack them into the values x, y, and z, right? So powers of 3 will return this tuple 3, 9, 27, and we're going to say unpack that tuple of 3, 9, 7 into x, y, z. Okay, and so what happens is x gets the value 3, y gets the value 9, and z gets the value 27 there, and they're all stored kind of separately. So you can unpack that tuple into x, y, z. Okay, is that good? It's kind of cool. If you wanted to, though, you don't have to unpack them. Okay, you can just say take the powers of 4 and store them into j. And in that case, j retains the structure of the tuple, and all 3 values are stored into j. So that's a possibility as well. And if you wanted to reference any one of these values, you can use single square brackets, much like you would subset a vector in R. You can use a single square bracket, so you can say, what is the 0 index value in j? And it will be, the first value is going to be 4, index 0. And j index 2 will be the third value, 64. So Python is a 0 indexed language in contrast to R or MATLAB or something. So just remember that j single square bracket 0 refers to the first value in the tuple, and single square bracket 2 would refer to the third value in the tuple. And this is just something that you kind of have to get your brain into and to switch, especially if you're switching between 2 languages here. And you'll have lots of debates with other people about which language is superior and whether things should be 0 indexed or 1 indexed. I mean, I don't think anybody cares. Well, some people care. I'm not particular to it. Okay. When you do tuple unpacking, though, you have to, if you want to do tuple unpacking, the number of elements to be unpacked must match the number of values being assigned. So, for example, if we said powers of 5 and I wanted to unpack it to GH, this causes an error. It says too many values to unpack. I've expected 2, right? So here we give it 2 spots, G and H, to store the values, but powers of 5 returns a tuple of 3 values. It's going to return 525 and whatever is next, 625. Okay, and it says, I've got 3 values to unpack and there's only 2 spots. So this creates a problem, right? So you need to have GHI or something, and you can unpack the values there. So the difference being, this works, unpacking the tuple into 3 values, that works. But I'm trying to unpack this tuple, which produces 3 values, into only 2 spots is not going to work. Okay, you just get this too many values to unpack. Okay, let's take a look at just how code gets executed inside Python. So when you run code, it always starts at the top, okay, the first statement, and we run them one at a time from top to bottom. And when you define a function, Python will just say, okay, you have defined this function, but the statement inside the function will not run until the function is called, okay? Oh, there's a question. Does it recycle? Like, what if there were 6 values? So if we're talking about unpacking, no, there's no recycling when it comes to unpacking. So other things in Python, like when you do NumPy, they do recycling. It's actually called upcasting and stuff, and things happen, but not with tuple unpacking. There's no recycling. So, but anyway, talking about a script, when you write a script, you can define a function, but that function, the statements inside the function do not get executed until the function is called, okay? And so a function call is basically like a little detour in the flow of execution. You're running code, it calls a function, and when you do that function call, it then kind of transports you to another place in the code where the function has been defined, and it goes into the body of the function. It runs those lines of code, and then once it reaches the end there, if it returns the hits a return statement or reaches the end of the lines, then it returns back to the rest of the code and picks up where it left off. So so let's look at a couple silly functions and how this might run. Okay, so so here I've defined a silly function, which is just going to be called print twice. It takes an argument. This argument we're going to call Bruce, just to be funny. All right, and all it does inside this function is going to just print Bruce. Okay, so it prints, it literally just takes the object, whatever it is, and it prints it twice. Okay, and so the arguments of function are assigned to variables called parameters. Okay, and so the function takes whatever argument comes in the function call, and that argument is assigned to a parameter named Bruce. Okay, and whatever the function it is, it's going to print this parameter, and it's going to print it twice. Okay, so here I'm going to say print twice spam, and we get spam. All right, here I've got math, and so here I'm going to write import print twice, and over here I execute some math. So this gets executed. We're going to do sine of pi halves. Okay, sine of pi halves, that gets evaluated to 1, and now it's going to print twice 1.0. So this value, math sine math of math pi over 2, that's going to get assigned to the argument Bruce. So then it takes on the value 1. Again, here inside the function, I'm giving it an expression, spam times 2. Okay, so the string spam times 2, and so I got spam space, and that's going to get printed twice. Okay, so whatever comes in here gets assigned to the thing. And so what's happening here? So now I've run print twice spam, and then the output of this gets thrown into print twice. So when we are executing the code, first it kind of goes into the innermost expression that needs to run. So it's going to call print twice on spam, and it prints spam 2 times. And then what? What does print twice return? Okay, if we look at the definition of print twice, does print twice return anything? It does not. There's no return statement. Printing itself doesn't return a value. So when you execute this, what does it return? It returns nothing. It doesn't return anything. Okay, so it returns none. And so in this case, after printing spam here and here, the value that gets returned, this expression is going to be evaluated to none. None gets assigned to the parameter. And so now it's going to say print twice none, and it prints none. I want to make sure this code chunk makes sense to everybody. Okay. So I think it's explained here. The inner print twice ran first. It printed spam on one line and printed spam again. The function print twice has no return value. It returns none. And so therefore, when you call the outer print twice, it's going to print the word none 2 times, or the none object 2 times. Okay. You can assign default values. All right, so if you don't assign default values and you try to call a function, then you're going to run into problems. So here is a very simple example. We're just going to take a function, stuff ABC, and it will just print out the values ABC. Okay, so I say stuff 1, 2, 3, and it prints out 1, 2, 3, and there you go. Okay. However, if I try to call this function with just 2 of the arguments, and so 1 gets assigned to the parameter A, and 2, the second argument 2 gets assigned to the parameter B, but there's nothing for C, then it complains. It says missing 1 positional argument that's supposed to get assigned to the parameter C. All right, so we get an error here. So now I can just say, well, you know what? Let's give it some defaults. Okay, so here's pretty much the same function, but we're going to call this junk, and it has 3 arguments, A, B, C, and it comes with default values. The default value for A is 1, B is 2, and C is 3. And so here, if I call junk with no arguments provided, it will just take the default values and will print out 1, 2, 3. If I call junk with just 1 argument, then it will get assigned positionally, and this will get assigned to the first argument, A, and so it will replace that 1 with 4, but then it uses the default values for B and C and prints out 4, 2, 3. I can specifically say assign 4 to the argument B, and it will replace the second argument B with the number 4, and so now it will print 1, 4, 3. So that works as well. And you can also specify just kind of positionally, and this will, 5 will go to A, 10 will go to B, 0 will go to C. That's fine. Okay. It doesn't like this if you use a positional thing. So here it says, so it complains and it says, I got multiple values for argument A, right? So it sees this, it says junk, and it says, oh, you're not specifying letters here. So I'm going to assign 5 to the first argument A. And then it's reading left to right. And then it says, wait a second, I just assigned 5 to A, and now you're telling me A should be the value 10. I don't know what to do. And so it complains and it stops. Okay. This is different from R's behavior. If you name some but not others, R is going to try to match these up. But the way Python works is it reads left to right, and it says, oh, this one's the first thing. It's going to go to the first argument, and then it gets upset that you're kind of telling it that A should actually be 10. Okay, so it doesn't like that. You don't have to go in order. You could say C is 5 and A is 10 and B is 0, and Python has no problem there, because right off the bat, it knows that we're using the names of the arguments to specify its values. So it doesn't get confused here. Before we go on, let me go ahead and give you your second view quiz answer. Second view quiz answer today is C, C as in cat. C as in cat is your second view quiz answer for today. C as in cat. Okay. The function variables and parameters, it's important to remember that these things are local, which mean that the values only exist inside the scope of the function. So here, I've got a function, print twice, and it's going to take this argument Bruce, and it's going to print it twice. Okay. And then I'm going to create a function called cat twice. Okay. And it's going to take 2 arguments, part 1 and part 2. It's going to join part 1 and part 2, using a string join. It's going to do part 1, adds a space, and then concatenates to part 2. And then it's going to call the function print twice with this argument cat. Okay, so using some lines from one of the greatest songs. We've got line 1, bitty bitty, and line 2 will be bomb bomb. And so we've got, we'll call cat twice, all right? And so it'll concatenate bitty bitty space bomb bomb, okay? And we got bitty bitty bomb bomb. And it's going to call print twice on this thing, right? So first it creates this thing. So cat takes on the value bitty bitty bomb bomb. Nothing has happened, but it's going to call print twice, and it prints out bitty bitty bomb bomb, bitty bitty bomb bomb. Okay. So we've got that. Okay. When cat twice terminates, this variable that we've created here, cat, okay, it's destroyed. All right. If we try to refer to cat in the global environment, we get an error. Any parameters that we have, it doesn't, these things don't exist, right? So print twice, and so out cat is not defined. And we ask, what's the value of Bruce? That's also not defined. These things don't exist outside of the scopes of these functions. They only exist while the function is running and only inside the function scope. So these things are not defined. If we saw this already, but if an error occurs during a function call, Python will often print the offending line. And so if the line is inside a function, it will print out kind of some contextual lines of the function, and it'll kind of keep doing a traceback until there is until it reaches the topmost frame, okay, which in general is going to be under main, okay, which is what we call here double under main. So the values that are not defined inside a function are defined in the frame. This is kind of your top level script environment, okay, double under main is here, okay. So for example, I messed with print twice here, okay, and it's going to try, so I've got print twice here, and inside print twice, instead of using the argument Bruce, it's going to use the argument cat. Okay, and it doesn't like this. It doesn't like this because cat is not defined inside the scope of this thing. So even though it's defined here, when you call print twice on cat, it executes this thing, but it's within the scope of this function. This argument is called Bruce. Okay, so here, if I try to execute that line, we get this traceback. Okay, so here it says, all right, the top level thing that you executed was line 1 is bitty bitty and line 2 is bomb bomb, and you called cat twice, and that's the offending line. Cat twice, line 1, line 2, that's where we're encountering the error. And so let me tell you, if you look inside the definition of cat twice, we were able to do this part. Part 1, part 2, join them together to cat, that's no problem. We encounter an error right here where it says print twice cat, okay? So the error encounters here, and therefore it says, okay, well, what is happening here? So inside the definition of print twice Bruce, now we are encountering the error right here, okay? Again, it shows you kind of where it's encountering the error. The error is encountering on the second line where it says print cat. And what is the error that we are encountering? Name cat is not defined, okay? And again, inside the context of this function, indeed, the name cat is not defined, and this is why we are encountering the error, right? So, a lot of times when you encounter error messages, it's easy to just throw up your hands and say, I have no idea what's going on or what this is. But I encourage you to take the time to read through the error message carefully, and a lot of times it will be helpful. Again, later on, sometimes we'll be loading packages like NumPy and pandas, and sometimes you'll encounter an error there, and it's a lot more challenging to interpret because you're reading someone else's code. But especially in these beginning assignments when you are writing your own functions, usually the error messages that Python returns will be quite helpful and quite handy for you to figure out exactly where something has gone wrong. Okay. And so I think, so this slide just kind of goes through exactly what I said, just without the nice coloring. And so let's take a look and just talk about the global scope here, right? So in here, I'm going to define this phrase cat. The object cat is going to be this line over here that says something else entirely. Okay, something else entirely. All right, and so now when I execute this, I don't encounter an error, right? So I still have the bad definition of print twice. I got print twice Bruce, but inside that definition, I'm saying print cat. Okay, and here print cat twice works fine. And so here I'm going to cat twice bitty bitty and bum bum, but then rather than printing out bitty bitty bum bum, it prints out something else entirely, and it prints it out 2 times. Okay, and the reason for that is because inside the definition of print twice, we're calling cat, and when it can't find the object cat inside its local scope, it's going to check the higher level, and it's going to find cat in the global environment, and it's going to use something else in this phrase, something else entirely here. So the variable cat is found in the global environment, and that is printed there. I hope that makes sense as far as how the scoping is working here. Within IPython, so this is not your regular, not a regular Python command. This is just something that works for IPython, which exists inside Jupyter. So when you're running Jupyter, you can kind of get a listing of all of the values that are defined inside the global environment by using what we call this magic command, %who. And you can also get more details using %whos, whos, as well as %who_ls. And so %who will just kind of list off the different objects that are defined in the global environment. So far, we've defined in the global environment cat twice. Whos gives us the details. So cat is a string, and it contains this value, something else entirely. Cat twice is a function that we've defined. Greeting is a string that we've defined, hi. Okay. J is a tuple with 3 objects in it. Okay, junk is a function, line 1 and line 2, these are strings that exist in the global environment. Math is a module that we've loaded, and and these are all of these different things that we've kind of created in today's lecture, right? And so these are things that exist that were defined inside the notebook, and therefore at this moment in time, these are the values that they've taken on. You can also, if you want to kind of try to refer to these things later, you can do who_ls. You get a list with the string names of all of the objects that exist inside the global environment. Okay, so that's one thing that I miss a little bit. When using Jupyter Lab or Jupyter Notebook, in RStudio, you kind of have this environments pane that kind of lists off all of those things. You don't have that in Jupyter or Jupyter Lab or things like that. But you still can get an idea of what are all of the things that have been defined inside the global environment. You just have to use kind of these magic commands, %who, %whos. These are things that you should just kind of run inside a thing without generally, it would not be recommended to call these from inside a function. Okay, calling this inside a function is not going to work. So just while you're kind of in interactive mode, it can be helpful to have. Okay, let's get into a few more scoping rules, and I gotta work a little bit quickly through this part. And let me go ahead and give you your last view quiz answer for today. Today's last view quiz answer is the letter C. C as in cat. C as in cat is your third and final view quiz answer for today, C as in cat. All right, so here, X takes on the value 5 in the global environment, and I can say, well, what is X? And it returns the value 5. We're going to define a function, alter X, and what it's going to do is it takes X, and it's going to add 1 to it, store it back to X, and yes, in Python, you can do things like plus equals 1 and things like that, and it will do this exact same thing. It's going to add 1, it's going to increment X and assign it back to X here, and I'm going to say return X. So when I call this, and I say alter X, and I put in X, X currently has the value 5, it's going to return the number 6. All right, so this is no surprise, but does it modify the value of X in the global environment? And the answer is no. Okay, so inside this function, even though this function did get executed, the X inside the function is separate from the X defined inside the global environment. These are separate scopes. Right, so when you call a function, basically operations and assignments that happen inside the function only happen inside the function and don't interact with values outside of the function. If you wanted to, you could use the keyword global. All right, and so here we're going to say alter Globalx, and it's going to take X in the global environment, and then we're going to add 1 to it, assign it back to X in the global environment, and return X. All right, you got to be careful when you use this. It exists and it allows us to interact with the global environment objects, but it can do stuff. So here I'm going to have X as 5. We're going to alter the global X, okay? And we'll get back the value 6. And X in the global environment now takes on the value 6, okay? So that's using the keyword Globalx. So if a function calls for a value that is not provided in the arguments and is not defined inside the function, then Python's automatically going to search for the value in the higher scopes. So in this function, we ask Python to print the value of X, even though we don't give it as an argument. So we're going to say print X, return X. And so it's going to search for this in the global environment. So we're going to say search for X, and it finds X in the global environment and it prints it. So it prints out the number 6 to the screen, and it returns the number 6. So the input is 6. Input is this statement. It prints out the object X, which has the value 6, and it returns that object X as well. So the scope order, okay, it goes in this order. So first, it's going to search the local scope. So inside a function, the scope is going to be, your local scope is the code block or the body of the Python function itself. And this is going to contain any names that you've defined inside the function, and any kind of parameters that come in. So when you call the function with arguments and those arguments get assigned to parameters, those things will all be available inside the local scope. If you have a function that is nested inside another function, we call that the enclosing or the non-local scope. So that is, if you have a function called from inside another function, that will be the kind of enclosing or non-local scope. So if the local scope doesn't contain it, then it will search the higher scope, this non-local scope, and that has all of the stuff defined in the enclosing function. Okay, and then you might have several levels of enclosing things, and then it will finally go to the global scope. So the global scope is the topmost scope in a Python program script or module, and this scope contains all the names that you've defined at the top level of a program. And this would be kind of visible from anywhere in your code, as long as it kind of reaches there. We have a question that says, what happens if there's no object X in the global environment? Well, then you encounter a name error. It's going to say name cat or object named cat is not defined, right? And we encountered that like way back here. So, I don't know, so somewhere else in the thing, we had an example where we said print. I think it was print twice, and inside the thing it said print cat, and then it complained cat wasn't defined. So if it can't find it in the global environment, you're going to get an error. Okay, but if it does find it in the global environment, then it'll use that value. Okay. You have a built-in scope, and that's going to be kind of created whenever you run a script or open an interactive session. And this is going to contain such names as keywords or functions or exceptions and other things that are kind of built into Python. So these also exist. So here we're going to define X, Y, and Z to be the values 1, 1, 1 in the global environment. Okay. And again, this is an example of tuple unpacking. And so this is kind of one nice little feature of Python, is if you're going to just assign a whole bunch of values, and you can just kind of give the values X, Y, Z and whatever values you want respectively, and it will unpack this, and it will do X is 1, Y is 1, and Z is 1, and whatnot. And you don't have to have 3 separate lines. And so here we're going to have a function. We're going to call it f, and all f is going to do is it's going to take the value 2 and assign it to y, and it's going to return x, y, z. Right? So when I say print f, what is it going to print? It prints out the tuple 1, 2, 1, because it's going to use the global value for 1, the local value for y, and the global value for z. Right? It searches for x, y, z in the local environment. It doesn't find X or Z in the local environment, so it's going to use the global values for those. It does find Y in the local environment, and so it's going to use that. So in this case, we get 1, 2, 1. But the values in the global environment are unaffected, and those remain 1, 1, 1. Okay, here I've got 1, 1, 1 in the global. I've got F, which defines 2 as Y is 2. And I've got inside F, I've got G nested, and inside G, we define Z to be 3. G is going to return X, Y, Z, and F returns G. So when we print F, it executes F, okay, and it says, okay, Y takes on the value 2, and then it skips down, right? It doesn't execute the definition. It skips down to here, and it says return G, okay? And so now when it says return G, then it executes this thing. And now we're inside a nested function. And this function says assign Z to 3 and return X, Y, Z. So it looks for X, Y, Z in the local scope. It only finds Z in the local scope, which takes on the value 3. It cannot find Y. And so for Y, it searches the non-local scope and it finds 2. It asks for X. It doesn't find X in the local. It searches the non-local scope. It doesn't find X in the non-local. So then it reaches the global scope and X takes on the value 1. So it returns, so it has a value for each of these things. It returns 1, 2, 3. F returns 1, 2, 3. X, Y, and Z remain unchanged in the global scope, global environment. And the steps of this are all kind of written out here. And I hope that makes sense. And it is now 9:50, and I got a couple more slides here. So notice the difference here. G is inside the global, F is inside the global. So what happens here, F defines Y to be 2, and then it calls G. So when we call F here, it defines Y to be 2 inside F, and it calls G. When G gets executed, G exists in the global environment, and inside G, Z gets the value 3, and it returns X, Y, Z. And so inside G, it's searching for X, Y, Z. It finds Z in the local environment, and it doesn't find X and Y in the local environment. Because G is defined in the global environment, when it searches, it can't find X and Y, it's not going to search inside of F. Okay, it's not going to search inside here. It's going to search immediately to the global environment. Okay, and then it finds X and Y are 1 and 1. And so this thing is going to return 1, 1, and 3. If you understand the difference between what is happening here and why we get 1, 2, 3, and why we're only getting 1, 1, 3 here, I think this is a key piece to help us understand the difference between the scoping rules in Python. Okay, and in all of this, so here's another example. And so there's a few more examples of scoping rules that I encourage you to kind of work through. And I apologize that we've run out of time here to go over this, but take your time working through some of these things and see if you understand and can explain why we are getting certain values for this. So here I've got calling global, and I've tried to give some comments here to help you understand what is happening inside of these things. So here I called global Z, and so now when I modify Z to equal 3, it changes the value of Z in the global environment. Okay, but anyway, we're out of time, so we'll end here for today. Thanks for sticking with me, and we will see you guys on Friday. So have a good day.